In this lecture, we talk about hardware of a computer system. So this is a diagram for a computer system. At the top levels, you can see that we have applications, operating system, and device drivers. They are the software of a computer system. And at the bottom layer, we have the hardware. Hardware components are usually the physical components that we can touch and see. So as mentioned in the introduction, input, storage, processing, and output are the four major tasks that a computer can do. So there are different types of hardware components that handle this task. For example, we have keyboard and mouse for the input. For storage, we have hard disk. For processing, we have the central processing unit, the CPU. And for output, for example, we have the monitor and the printer for outputting the results to the user. So we have different types of computers for different purposes. For example, we have special purpose computer embedded in tools and appliances, for example, smart card or set-top box. We also have the desktop computers, which are actually the ones that you're using in the lab. And we also have the notebook and tablet, which are more portable, and also the smartphone, which are even smaller. We also have the server and the mainframe computers, okay, which are more powerful and can serve many users, right, at the same time. So these special purpose computers are really designed for very special functions. For example, the TV set-top box, they are for TV services. The routers, they are for networking. And also we may have consoles, right, for gaming. So the desktop computers are really intended for personal use. So that's why we call them personal computers, PC. And they're actually the ones that you're using in the labs. So notebook computers or laptop, they are smaller in size and more portable so that it can be carried around and use it anywhere. Nowadays, some of the laptops or notebook, they are very powerful. They are powerful enough to replace desktop computers. So we also have the tablet computers. Compared to notebooks, they are usually smaller and lighter, but with less computing power, and they are usually operated by touching the screen. So for smartphone, it's usually even smaller and equipped with telephone functionality. It's called the personal digital assistants in the past. So we call it PDA in the past. So servers, they are special purpose computers that provide services to other computers. Usually they are having higher computing power because they have to handle a number of simultaneous access from the users. A very good example of server is the email server that support the email application of all the UST members. So these are the even bigger and more powerful computers, and we call them mainframe and supercomputers. For mainframe, it typically has sufficient computing power to support hundreds of simultaneous users. A very good example is a bank computer that manages all the customers' account data. For supercomputer, it's ultimate in computing power. That means that it's very, very powerful, and often it occupies the entire floor of a building and is dedicated for very complex computation. For example, it's used for creating weather reports or is used for scientific research. So how do we determine the speed of a computer? It's important because the speed categorizes the power of a computer. So for computer, usually we are talking about hertz. That means that number of instructions that a computer can execute in 1 second. If we are talking about 1 hertz, that means that the computer can execute 1 instruction in 1 second. If we are talking about gigahertz, right, then we are talking about 10 to the power 9 instructions in 1 second. This is a relative measure for comparing computers in the same series only, because there are other important factors that can affect the speed of a computer. So now let's talk about how data are represented on computers. So for computers, we store data as a sequence of zeros and ones when we call them bits. A group of 8 bits, we call it a byte, and 1024 bytes, we call it a kilobyte. 1024 kilobytes, we call it a megabyte, and so on and so forth. So nowadays, we are talking about gigabyte and terabyte of data. That means that we have many, many zeros and ones stored on a computer. So now let's talk about hardware using a real-life example. Let's say that you want to buy a notebook or desktop computer from the ownership program. Then which one should I pick? So when you buy a computer, usually you would be provided with a pamphlet like this. So showing different computers with different specifications, for example, with different CPUs, memory, hard disk, display, and etc. etc. So we'll talk about all these components later on using this example pamphlet. So if you want to learn more about the components of a computer, for example, the CPU, RAM, hard disk, display, etc., etc., there's an excellent introduction at this website, computer.howstuffworks.com. And I really recommend that you go there and take a look. And we'll also talk about all these components one by one later on in this video. So just keep in mind that the components of a computer serve four main functions. And we have already talked about these four functions. They include input, storage, processing, and output. So for acquiring information for input, we have input devices, for example, keyboard, mouse, and webcam. For storing, we have RAM and hard disk. For processing and communication, we have CPU, Wi-Fi, and network cables, etc., etc. For presenting or outputting information, we have display, printer, and speakers to output information to the users. So for input, the first input device that we are going to talk about is the keyboard. It's the standard input device, and it has similar key layouts, but different key assignments for different languages. So the second input device that we're going to talk about is the mouse. It's a pointing device invented in the early 1960s, and it became popular when Macintosh was introduced in 1984. So in the picture, you can see that this is the first computer mouse, and it's sort of clumsy and sort of big comparing to the ones that we're using now. So the modern design is very nice and easy to handle comparing to the first mouse. For the newer pointing technologies, we have touchscreen and also the motion sensor, for example, the NIP sensor. We also have the Magic Mouse and the Magic Trackpad, which support multi-touch gestures on top of the normal mouse and the touchpad functions. So for display monitors, for the output, the old ones are called Careful Rate 2, so the CRT. So they are quite bulky and big comparing to the ones that we're using now. And the one that we're using now is called the LCD display. And we also have the plasma display, which are usually for TVs. When we talk about display specifications, we talk about things like the screen size, which is the distance between the two opposite screen corners, as shown in the picture. And we also talk about the resolution, which is the number of picture elements or the pixels that a screen can display. We also talk about the response time, which is the time needed for a pixel to go through an on and off process. The longer the response time, the more likely that we will encounter blurring effect. For example, in this pamphlet, you can see the screen size of the display. It can be something like 11.6 inch, 14 inch, or 15.6 inch. And then the number inside the bracket shows the resolution of the display. It can be low as 1366 times 768 resolution, or it can be as high as 3840 times 2160. So to connect different devices to a computer, we need different cable connectors. For example, we need to connect power, keyboard, monitor, mouse, etc., etc. to a computer. And to prevent connection mistakes, usually all the cable connectors are different in shape, and the connectors can only be plugged in one way. So for computer cables and connectors, the common one is the USB, which is the standard connection method for many devices, for example, your mouse, your keyboard, and your printer. For display and multimedia, we have VGA, DVI, DisplayPort, and HDMI. For networking, we have the Ethernet cables. Again, in this example pamphlet, under ports and media, we can see the connectors supported by the computers. For example, all the computers are supporting USB 3.0, which is having a higher bandwidth comparing to USB 2.0. Some of them are supporting the connector RJ45 That means that those computers are supporting Ethernet cables. For display, they are either supporting HDMI, VGA, or DisplayPort, DP. So let's take a look at the inside of a computer. So basically, a computer has the following components. First, we have the central processing unit, which is the CPU, memory, hard disk, optical drive, motherboard, and graphic card. We will talk about them one by one. So if we are talking about the central processing unit, it's really the brain of the computer, and it contains millions of transistors, and is used for mainly performing arithmetic and logical functions. If we are talking about the IBM 7094, it's released it in 1963, and the price is very expensive at more than 1 million US dollars. If we are talking about nowadays, right, an Intel Core i7 at 3 gigahertz only costs less than 300 US dollars. So let's go further and talk about the CPU specifications. So CPU from different manufacturers can have different designs. For example, they can come from Intel or AMD. And a family of CPU means a group of CPU with similar design. So for Intel, we can have Core i7, Core i5, or Core i3. For AMD, they have the A-series APU, which is a combination of the CPU and GPU, the graphic processing unit, on a single chip for better 3D rendering and video playback. So if we are talking about the speed of a CPU, we know that we are measuring the speed of the CPU using gigahertz. And the number of cores means the number of units that can execute instructions or commands concurrently. So if you're talking about single core, that means that we only have one processing unit at a time for executing the instructions. If you're talking about dual core, that means that we have two processing units for the command executions. So if we take a look at this pamphlet again, we can see that all the computers are using CPU from Intel, because this year Intel is dominating AMD. And for the family of the CPUs, we can see that some of them are using i3, some of them are using i5, and some of them are using i7. If we are talking about the clock speed, all right, some of them are at 2.2 gigahertz, some of them are at 2.6 gigahertz. And if we are talking about the number of cores, for the high performance one, we have quad core, so we have 4 processing units operating at a time. So for storage, there are different types of memory that we can use. For example, we can use the random access memory, the RAM, or the read-only memory, the ROM. For ROM, that means that if we have written something to the ROM, we cannot change it later on because it's read-only. And we can also use the flash memory, which is used for USB thumb drive and your SD cards. So now let's talk about the random access memory, the RAM. It's for storing instructions and data manipulated by the CPU. Since RAM is much faster comparing to hard disk, anything processed by the CPU has to be moved from the hard disk to the RAM before the processing. And it's for temporary storage only, what we call the volatile storage. That means that if we switch off the computer, then all the memory is gone. And it contains millions of transistors. And of course, the more memory, the better the computer. And if we talk about nowadays, typically a computer will have at least 4 gigabytes of memory. So for the RAM specification, first we talk about the capacity, which can be either 2 gigabyte, 4 gigabyte, 8 gigabyte, or 16 gigabyte. For the speed, we are measuring the speed in terms of the data rate, and we can be using either DDR2 or DDR3. And of course, DDR3 is faster than DDR2 because it's having a higher bandwidth. And they can have different clock speed as well. Okay, we are talking about something like 1066 megahertz or 1333 megahertz. So let's go back to this pamphlet again. We can see that all the computers are using DDR3 at 1600 megahertz. And some of them are having lower capacity, lower memory capacity at 4 gigabyte. And some of them are having more memory at 8 gigabyte. So now let's talk about hard disk. It's a magnetic permanent storage of instructions and data for transfer in and out of the main memory. It's mechanical, that means that if you want to read or write something to the hard disk, you have to move the read and write head to the correct location before you can read or write something to the hard disk. It's non-volatile, that means that if you write something to the hard disk, it's going to exist there unless you delete it. And of course, the larger the hard disk, the better the computer. Typically nowadays, we are talking about hard disk with 1 terabyte or 2 terabyte of storage. So this is a picture showing an example hard disk module. So for the hard disk capacity, we are measuring it using terabyte. So the capacity can be something like 1 terabyte, 2 terabyte, or even 3 terabyte. So there are two different types of hard disk that we can use. For the smaller one, the 2.5-inch one is used in notebook computers. And for the bigger one, 3.5-inch, they are usually used in desktop computers. And the rotational speed of a hard disk determines how fast the disk can rotate or spin. So the faster, of course, the better. So for permanent storage, we can also use the solid-state drive, the SSD. It's using flash memory for the storage, so it's much faster comparing to hard disk. It has no moving parts. That means that it's less fragile comparing to hard disk. It has lower power consumption, more silent, and low mechanical delays. But of course, it's much more expensive comparing to hard disk. So going back to this pamphlet, we can see that some of the computers are using hard disk for the storage, and some of them are using SSD, which is much faster comparing to hard disk. So for optical disk, it's an optical storage of instructions and data. That means that we are using laser to read and write data onto the optical disk. So it's a standard medium for backup. So if we are talking about a CD, we are talking about a storage size of 700 megabytes. If we are talking about DVD, we are talking about something like 4.7 gigabyte of storage. So nowadays, we also have the Blu-ray disc. So it's officially released in 2006, and it uses blue laser instead of red laser for larger storage. So it's designed to replace DVD. So if we are talking about the storage, Blu-ray offer 25 gigabyte for single layer, 50 gigabyte for dual layer, and 100 gigabyte for triple layer. So it's much larger comparing to DVD. So this is a diagram showing the different laser beams used by CD, DVD, and Blu-ray. So these are some of the devices that use Blu-ray disc as the storage media. We have a video player and PlayStation 3. For optical drive specifications, an optical drive may support different types of media, for example, CD, DVD, or Blu-ray. It may support different read or write speed, for example, 4 times, 8 times, or 16 times. It may support other features, for example, dual layer recording will allow DVD to store up to 8.5 gigabyte of data. If you have light scribe, that means that it will allow labels to be burned onto the disk. So next we talk about motherboard. So basically every computer has a motherboard, no matter it's a desktop computer or laptop computer. So it's a circuit board to mount CPU, RAM, and all the other hardware components together. It's an intellectual property of PC manufacturer. So this is a typical motherboard of a PC. So you can see that there are lots of connectors and slots for different hardware components. So another important hardware component is the graphic card, especially if you play video games. It outputs everything to the display monitor for you to see. It contains a graphic processing unit, the GPU, that performs complex 2D or 3D geometric calculations. So that's why it's important for gaming. And for the integrated on the motherboard display card, usually they are for low-end models. For example, the Intel HD graphics. For graphic card specification, basically it's very similar to CPU specifications. The GPU can come from different manufacturers, for example, NVIDIA, AMD, or Intel. And they can belong to different model and family. For example, for NVIDIA, they have the GTX series. For AMD, they have the Radeon series. For memory, each display card has its own memory for display, and more memory is needed for complex graphics or for high resolution. For example, 1 gigabyte or 2 GB. So going back to this pamphlet, we can see the different graphic cards used by different computers. And notice that the NVIDIA GeForce 940M and the 960M, they are much more powerful comparing to the Intel onboard HD graphics. So printers and scanners. Printers are for producing hard copies of the documents. There are different types of printers that we can use. For example, inkjet with low cartridge cores. And we also have the laser printers, and they are precise and good looking. We also have special purpose photo printers for printing photographs. For scanners, they are used for producing soft copies of documents, and they are useful and environmental friendly. Nowadays, often printer and scanner, they are combined together as an all-in-one device so that we can do printing and scanning all at once.